All right, hi boys. So today you've obviously got a relief teacher, so be nice to them and behave. But we will be continuing on doing our circuits and electricity. So today we're going to work on success criteria 7, defining currents, resistance, resistors, conductors, insulators, electrical potential, and potential difference. We will also be stating the units for current, voltage, and resistance. And if we get time, we will recognize what a series and a parallel circuit is. So first, let's start with our current, okay? Now, we looked at current the other day and we defined it as being the movement of charged particles, okay? Of charged particles. And those particles, okay, are our electrons. Okay, so remember they're in the outermost part of our atom and they can move freely. Now we denote current using the letter I, a capital I. Don't ask me why, that's just what we denote it with. So whenever we're saying current, we can write capital I instead of having to write out the two word. Now, we have two types of current, which Joe mentioned just the other day as well. They also might remind you of a famous rock band from, I think it was around the 80s, okay? And our two types of current are your alternating current and your direct current. Now, your alternating current, okay, is when your electrons can shuffle back and forth along a wire. So what that would look like is, or how it works, is not dissimilar to particle theory when we're looking at heat waves. So what happens is, if you remember back to yesterday when I acted as the battery and you guys were the electrons, I had a positive side and a negative side. Now that caused you all to move in a given direction. Now what happens with an alternating current is my positive and negative terminals will switch. And they can switch quite often, but it means that the electrons travel back and forth. They don't keep moving in the one direction. Okay, so an example of when you might see or use an alternating current would be for a power point. Okay, so when you think about it, your power point needs to be able to have electrons going forward into your device and also back. So that's where you've got that third little prong on your power cable. Okay, that's actually a grounding prong. So if anything were to go wrong, the electrons would flow back into the grounding cable and into the earth so that you were not harmed. Okay, the power also goes back, so it starts and ends in that one power cable. Okay, so that's as far as we're going to go with alternating current, and we're more going to concentrate on the other type, which is your direct current. Okay, so we've got direct current. Or DC. So we've got AC, DC. Okay, now your direct current is the one we enacted yesterday. It's where all your electrons flow in the same direction from the negative terminal to the positive terminal. And an example of one such device, that uses a direct current might be a battery. Say a battery that you've got in a torch. Okay? Now when we measure current, we established the other day, we measure it using a device called an ammeter. Okay? And it's measured using units of amperes. So we measure it using an ammeter. Let me just double check my spelling. Double M. Okay. And is given in amps. Or in full word is amperes. Or amps for short. Okay, so that is your current. Now when we're looking at current, okay, if you were to increase your electron flow, okay, you would be increasing your current. All right, so I'm going to pause this video here and we'll move on to voltage in the next video.